Welcome back to our series. Today we're exploring one of the strangest tricks of reality, length contraction. In our everyday lives, a meter is a meter, but in Einstein's universe, space itself is flexible. When things move at near light speeds, they don't just move faster, they actually take up less space. This phenomenon is called length contraction. It's the shortening of an object along its line of motion. It isn't an optical illusion or a mechanical squishing. It is the very geometry of space changing. Crucially, this contraction is relative. What you see depends entirely on how fast you are moving. To calculate exactly how much space squishes, we use the Lorentz transformation formula, which governs the heart of special relativity. Here, L is the observed length, L0 is the length at rest, and V is the object's speed relative to the observer. And C, of course, is the constant speed of light. Notice that as V approaches C, the observed length approaches zero. We see this in action with muons. These subatomic particles travel so fast, they see Earth's entire atmosphere as a thin sliver. From the muon's perspective, a journey of many kilometers is contracted to just a few hundred meters, allowing them to reach the surface. In labs like CERN, protons moving at ultra-high speeds see the entire 27-kilometer accelerator ring as a flattened, narrow pancake. Let's look at the numbers. At 90% the speed of light, a massive 100-meter starship would appear to us as only 44 meters long. At 99.9% of light speed, that same ship shrinks to just 4.5 meters. The universe becomes incredibly thin in the direction of travel. So why don't we see cars or people squishing on the highway? Because our everyday speeds are far too low to notice. Even the fastest jet is standing still compared to light. The contraction is mathematically there, but it's too small to measure. This tells us that space is not just an empty stage. It is a dynamic fabric that reacts and bends according to motion. Physicists view length contraction as a kind of rotation within the four dimensions of space-time, where space and time are linked. Remember, there is no single true length. Every observer's measurement is equally valid in their own frame of reference. To summarize, the faster you go, the more space squishes in front of you. It's an immutable law of our cosmos. It challenges our basic intuition, but it's been proven time and again by the most precise scientific experiments. Next time, we'll see how this squishing leads to the most famous equation in history, E equals mc squared. You won't want to miss it. I'm Albert Einstein. Subscribe to James's Physics 101 to master the fabric of reality and join us for the rest of this 10-lesson series. Keep exploring, and I'll see you in the next lesson.